TRAC is a universal model orchestration solution. You can use it to run almost any model, but it's designed for the most complex and critical use cases, including those which inform accounting, regulatory calculations, and disclosures. The platform is built around three principles. First, models, data, and workflows are protected from accidental corruption, so model developers and users can self-serve with confidence. Second, governance-ready documentation can be automatically produced at the push of a button. Finally, the platform allows you to safely use the same environment, model code, and data for both production and experimental model runs. The rest of this video explores four things: how TRAC integrates your existing technologies to create a single ecosystem in which to build, deploy, and use models. The platform's approach to model orchestration, called the Virtual Deployment Framework, TRAC's unique guarantee that every action is auditable, every calculation is repeatable, and there is no change risk on the platform. Finally, how TRAC allows you to safely execute experimental model runs using production data, code, and infrastructure. TRAC brings together multiple technologies to create a single ecosystem in which to build, deploy, and use models. For data storage, this could be any of the main cloud platforms, Hadoop, or a local disk. Whichever technology is used, there must be an area to which only TRAC has write access, which we call internal storage. All models executed on TRAC are stored in a repository, with the code being accessed only at runtime. Ideally, this would be a standard version control system, but custom repositories are also supported. Finally, TRAC uses an external compute service. For cloud deployments, this is typically Kubernetes, but you could use Hadoop or local execution. There are three additional integration points. First, TRAC's runtime service can be deployed to your development environment, allowing you to build models that translate to production with no code modification. Second, connecting external storage locations for importing and exporting data. Finally, integrating with your SSO mechanism to credentialize and authenticate users. All deployments create a version of this ecosystem in which TRAC integrates your data and compute technologies, code repositories, and development tools, providing the framework for process orchestration, versioning, lineage, and fine-grained permissions. TRAC's approach to model deployment and orchestration is called the virtual deployment method. Central to this is the metadata model. Everything that happens on TRAC is recorded, described, and controlled by metadata. The model is more complex than we will explore here, but we need to become familiar with the most important object types: data, models, flows, and jobs. Data can be imported using a batch process or loaded through the UI. As new records are created, TRAC also creates a new metadata object, which refers to and describes the data. This contains the data schema, information about its physical storage, and a raft of other information which is used for audit and platform control purposes. To make your models available in TRAC, they must be imported from a repository. At this point, the model code is not copied, amended, or moved. Instead, TRAC creates an object called a model schema, which describes the parameters, inputs, and outputs of the model, plus its coordinates in the repository, so the code can be accessed when needed. A flow is a reusable blueprint of a calculation that TRAC can run on demand, where the outputs of one model become the inputs to the next. They're built on the platform using the Flow Builder tool. Each flow describes one possible way that a group of models can be combined into an execution process. We call them virtual deployments because flows exist only as metadata objects, and are built from the model schemas, not the underlying model code. To run a calculation, or in TRAC language a job, you first select a flow, then confirm the model versions, data inputs, and parameter values to use. TRAC fetches the code from the repository and the data records from internal storage and runs the calculation via the execution service. Two new metadata objects are created, one which corresponds to the output data and one which describes the job itself. The job record describes the calculation in full and underpins the TRAC guarantee. On TRAC, every action is auditable, every job is repeatable, and there is no change risk. Every job generates a summary report, which contains details of the flow, the parameter values used, the model versions and data inputs, and the outputs that were created. Unlike traditional platforms, this is not retrospectively compiled from log files. This is the actual instruction that was used to orchestrate the job. To understand how we go from auditable to repeatable, we need to talk about version control. In the job report, every model has an object ID. Critically, this points to a specific code commit, which will never change, even if newer versions of the model have been uploaded since the job ran. The same principle applies to data. TRAC uses an append-only data model, so each ID points to an immutable snapshot of the data as it was when the job ran. Because TRAC remembers how every job was constructed and can recover the precise versions of all the inputs, any job can be rerun in full, and the outputs will match the original result, guaranteed. The implications for change risk are profound, because every version of every model and data set are permanently available, and any job can be rerun in full with just a couple of clicks. Model developers and model users can self-serve with confidence. Change risk has been eliminated. We've already seen how every calculation is auditable and repeatable. Now we will explore how the virtual deployment framework enables experimentation and analysis. The first approach uses experimental flows. Flows can be created for all types of analytics, from production calculations to sensitivity analysis and model monitoring. In the virtual deployment framework, these experimental or analytical flows can be safely run using production models, data and infrastructure, alongside your most critical and highly governed calculations. The second approach uses experimental inputs. When launching a job, TRAC automatically picks the latest object versions to populate the flow, but these can be switched out. Selecting a different model version allows you to run champion-challenger analysis on production data with just a few clicks, and the same principle applies to data inputs and parameters. These alternate objects do not need to be preloaded. Importing a new data set or model version makes it immediately available for use. Because of TRAC's unique virtual deployment method, executing these experimental jobs has no impact on any in-governance models or processes.